Hi to all. Welcome back to JP Physics Academy. This is Naresh Babu Javaji. Students, the last video we successfully completed that first application of dimensional formula. So actually we have three dimensional formulas. So out of the three application formulas, first one we completed in the last video. That is we can change the units of any physical quantity from one system to another system by use the dimensional expression, dimensional formulas. Okay. Now in this video, today in this video we are going to discuss about the remaining two applications of the dimensional formulas. Okay, now what are those? Let us discuss now. Let's go to the video. So the second application of the dimensional formulas is dimensional equations is to correctness of the dimensional equation. Okay, to correctness of the dimensional equations. Whatever the equation, whatever the expression will give you, that expression whether it is right or wrong, we can check by use this dimensional formulas. Okay students, how it is, let us discuss now with an example. So first of all, an example is, let us consider an expression that is t is equals to 2 pi into square root of L by G. 2 pi into square root of L by G. Students, it is an expression for finding the time period. Okay, t for time period, 2 pi is the dimensionless quantity, it is a constant, and L is the length of the pendulum, and G is the gravitation. Okay, so now let us check whether this expression is right or wrong. Okay, now by use the dimensional formula. So we can check or we can check this expression whether it is right or wrong by use the principle of homogeneity. Students, already we discussed the concept of principle of homogeneity in the previous videos. Okay, what is the principle of homogeneity? Whatever the terms which are present in this expression, those dimensions must be equal. Okay, na? Here suppose t is equals to 2 pi into square root of L by G formula is there. This expression is there. This is a dimensional expression. Okay, na? This is general formula actually. So whatever the dimension of time period, that must be equals to whatever the dimensions of this ratio with the square root, that must be equal. Means whatever the terms on both sides of the equal, this dimensions and these dimensions must be equal. That we are calling as principle of homogeneity. The terms which are both sides of the expression, the dimensional equation, should have the same dimensional values. Okay, na? That is the principle of homogeneity. Means if these dimensions and this ratio of the dimensions, if they are both of them are equal, then it is correct. Otherwise, it will be wrong. Okay. So time period. First of all, let us check by each and every one. First, let us take the right hand side. So from right hand side, RHS side, what is that? Square root of L by G. Because of 2 pi is a constant values, which is a dimensionless quantity. Okay, now, of course, some constant values are also having some dimensional formulas, dimensional values also, but unfortunately it is a constant value, it is a number. That's why there is no any dimensional values for this 2 pi. So here square root of L by G is there. Let us find out the dimensional formula of this dimensional formula, including the dimensions of this expression. What is that? Square root of L by G is there. Here L for length. What is the dimensional formula of the length? And L1 by. What is the dimensional formula of the gravitation? Gravitation is also nothing but that acceleration. That is due to the gravity. We can consider that acceleration and gravity two are same. That means dimensional formulas are same. So what is the dimensional formula of the acceleration? L1 t minus 2. So this L1 gets cancelled. Then finally what we got here? So t minus 2 is there. Send this t power minus 2 from denominator to numerator. It becomes to the plus 2 t2 t square. That is equal root of t square is nothing but t. So it is the right hand side. What is the left hand side here? What is the left hand side here? Again t is here. So what is the dimensional formula of this time t1? What is the dimensional formula of the time in the right hand side? T1. Means on both sides, whatever the terms are present, those dimensions are equal. So T1 and T1. That's why the dimensional formula of the left hand side of the equality, the dimensional formula of the right hand side of the equality, two are equal, and those dimensions are also equal. That's why whatever the expression was given here, that will be right. That is the correct. Okay. If unfortunately if you are not getting that same dimensions on that same terms, okay, on both sides of the equality, that will be considered as a wrong statement. I mean wrong expression. Is that clear, Andy? Then let's go to the third application of the dimensional formula. What is the third expression of the dimensional formula? The third expression of the dimensional formula is to derive that, to derive the relation between any physical quantity, any physical quantity. Students, in the first two applications, when they given the formula, based on the formula we can find out that one. We can change the units from one system to another system. We can check that expression whether it's right or wrong. Okay, when based on the formula. But in this third expression, the third application is, they won't give you the examinations. They won't give you that expression, means formula. Okay, but sorry, we should find out that expression by use this dimensional formula. Okay, how it is, let us see now with an example. Let us take an example. Sorry, the speed of sound, in solids, the speed of sound in solids is let me say v. Students, the speed of the sound is not same in the different media. So the speed of sound is different in different media. Of course, in the air one speed is there. I mean, it travels with one speed. In the solids it travels with one speed. In the liquids it travels with one speed. Okay now. So because of the depends upon the elasticity of the different media. Okay, then means that here speed of the sound in solids which is depends upon the elasticity. It is very important, and the elasticity of the medium, okay now, which is represented by E, and the density of the medium. It be as D. Okay now, means whatever the speed, whatever the sound which is traveling through the solid, that speed which is depending upon the majorly two factors in the solids. What is the first one is the elasticity of the medium, I mean solid, and that density of the medium. Okay now, let us consider how it is. Let us do it. So what is the relation among these things? So speed speed of the sound in a solids which is directly proportional to the E power A and D power B. What are these A and B? A and B are the constants. Okay now, let us, our aim is we have to find out this A and B constants. So in this case, what is the relation among this E, D and B? The speed of the sound in solids is directly proportional to the elasticity and density of that medium. Okay students, then so if you want to reduce this proportionality and replace it by the equal, then V is equals to K into E power A into D power B. Means here the K is the proportionality constant, and okay now, let be as proportionality constant. Of course, it is a dimensionless quantity also, dimensionless physical quantity also. Okay, it is a number. Okay now, then let us write the dimensions or dimensional formulas. Let us write the dimensional formulas of above physical quantities. What are those? What is the left hand side of this expression? Speed. Means what is the dimensional formula of the speed? m0 l1 t minus 1. That is the dimensional formula of the speed. And what is this elasticity? What is the dimensional formula of the elasticity? And m1 l minus 1 t minus 2. This is the dimensional formula of the elasticity. And what is the dimensional formula of the density? m1 l minus 3 and t0. These are the dimensional formulas of the V, E, D, means speed and elasticity and density of the medium. So let us take these dimensional formulas and substitute in the expression. Let it be as expression A. So in this case, substitute these values in equation A. What are those under here? So in this case, let us let me erase this left hand side and so what is the expression again? V is equals to k into e power a into d power b. Then let us substitute this dimensional formulas, dimensional expressions in the given expression. What is the dimensional formula of speed and m0 l1 t minus 1, that is equals to k is the dimensionless quantity. Then e power a means m1 l minus 1 t minus 2 power a. And what is the dimensional formula of the density? m1 n minus 3 t0 power b. Okay, then m0 l1 t minus 1 is equals to k into sorry, let us multiply this one. Let us multiply this m1 power a means ma, because of a power m whole power n is equals to a power mn is there na, according to the algebraic expression. So m1 whole power a is equals to ma and l minus 1 a, l minus a, t minus 2 power a is equals to minus 2a. This is okay. Then after m1 power b is equals to mb and l minus 3 power b is equals to l minus 3b and t power 0, because 0 into something is equals to 0. Then m0 l1 t minus 1 is equals to k into, students, let us multiply these things only because of ma here and mb here. So bases are same, powers we have to add a plus b, m power a plus b into length. Bases are same, powers we have to add length power m minus a is here and minus 3b is here, minus a minus 3b into t power. Here minus 2a is there, here 0 is there. Minus 2a plus 0 is equals to minus 2a. Then after, let us equate the m terms, l terms, t terms, means the dimensions of m mass, the dimensions of length, the dimensions of time on both sides. Okay na? Then what is that? What is the dimension of mass in the right hand side? A plus b, and its dimension on left side is 0. So a plus b is equals to 0. Then what is the dimension? What are the dimensions on both sides of the length and the minus a minus 3b is equals to plus 1. So after that, what is the dimensions on both sides of the time? Minus 1 is equals to minus 2a. So this minus is cancelled. Then what is the remaining here? 1 is equals to a. From this a is equals to 1 by 2. Students, this is the procedure. So after that, let us take these values. So we found that a value here. We found the a value here. Then a plus b is equals to 0 we got here. Then b is equals to minus a. Then b is equals to minus. Already we got the a value. We found the a value here. Substitute here 1 by 2. Students, in this case we found that a is equals to plus 1 by 2 and b is equals to minus 1 by 2. We got the values. So we required also a and b values only. Okay, a and b values only. Let's take this a and b values, substitute in the expression. Then v is equals to k into e power, what is the a value and d? Plus 1 by 2 into, what is the d power, what is the b value and d? Minus 1 by 2. So students, v is equals k into e power 1 by 2 means that root e. Let us write it as a 1 by root d, because of we can write it as 1 by d power plus 1 by 2. Then we can write it as root d. Then v is equals to k into under root a by root b is equals to, we can write as root a by b. So here root e by root d is here. That's a root, we can write as a root e by d. So finally, the speed of the sound in solids, the expression is v is equals k into square root of e by d. This is the expression. This is the relation among the speed of the sound in solids and elasticity of the solids and d means density of the medium, solid medium. Okay students, so this is the method, this is the procedure to find the relation among the relation between the more than one physical quantity, any physical quantities. And this is a method by use this dimensional formulas. We can construct the relation among the different physical quantities. Okay, students, this is the method and these are the applications of the dimensional expressions. Once again, students, we have the three applications of the dimensional formulas. First one is we have to change the units of any physical quantity from one system to another system by use the dimensional formulas. And second one is to correctness of the dimensional expression, dimensional equations by use the dimensional formulas. And third one is to to construct the relation or to derive that relation between any physical quantities, to find the relation between any number of physical quantities by use the dimensional formulas. So these are the applications of the dimensional formulas and dimensional expressions. So these methods we are calling as the analysis of the dimensional methods of the analysis. So means we can find out the applications of these dimensional formulas by the procedure of means that the dimensional formula, the dimensional expression or dimensional equations of analysis, or dimensional methods of the analysis. So different names are there. So this is the method, and this is the method for discussing the applications of the dimensional formulas. Okay, students. So this is the end of today's class. Okay, end of this today's class. So if you like this video, please like, share and comment about this video and comment on this video. Okay, but don't forget to subscribe that our JP Physics Academy YouTube channel, and please click on the bell icon for getting the first notification. Okay, this is the end of today's class. We will meet again in the next video and have a great day. Bye.